put stuff in your memory cells for those types of things. But there's very few things you're going to find that I will pound on time and time and time again, like this is. And it's come from just seeing that this is one of the most beneficial things I can do or ask you to put in your long-term memory that will benefit you in the drawing process. When we get structural and architectural, if you've got these memorized, you're going to love it, because you are running these all the time. You don't really use fractions in CAD, but what your whole drawing spec'd out as in the architectural unit of measure, it's all fractions. So we got to kind of be ambidextrous on that. You know, it's kind of like metric to English. If I worked in a place that was doing that constantly, I'll tell you what, I would find some time where I could sit down and I would start memorizing those different conversion factors, what the different ones are. Do you know a 12 millimeter is equal to a ½ inch? Those of you that run mechanics or work with wrenches, you probably do. Because you can't work on a car with just a standard English set of wrenches anymore.
Crap.
Depends on your workplace on what you do, but we use a lot of cheat sheets. We use a lot of things on our desks that we do. This is one that I think is important that you put in your mind. All right, any questions? Oh, wait, we didn't do the bonus, did we? Where's my stuff on the bonus? On the bonus, I was looking really for something kind of like this. You got a point for the definition, you got a point for the drawing. Okay. So a counterbore provides a recess for a fastener head. So you'd get 1 point if you were on this. And really all I was looking for, saying a fastener head needs to go below the surface. And then the diagram. The spot space provides a finished surface for a fastener head. Countersink. Excuse me if I don't have that one shown. Countersink's the same as a counterbore except for sloped head fasteners. Get it below the surface. So a possible 6 points. Any questions on those? Great. Can I get those back? If you've got your little sectioning worksheet that had your rules of sectioning on it, we're going to go through that. We're going to be on this top portion of the sheet I handed out on Friday. This is the last information on Chapter 16 we're going to hit. Tomorrow we'll do a test review, and we'll test on this on Wednesday. All right, let's go through these 8 guidelines on what to do when sectioning. So I've put down some stuff. I've added a couple onto my notes, and you can add those if you wish. So number 1. All visible edges and contours beyond the cutting plane line should be shown. Notice what it says here. All visible edges beyond the cutting plane line. So only things that appear with an OBJ line. So let's look at a couple of examples of this. Let's start with figure 16.9. on page 764. All visible objects beyond the cutting plane line should be shown. And there's many examples in this text. I'm just going to use two. A counterboard is a good example of this one. Because really, if we look at it as on the section line, what we've got is this portion. Well, let me just kind of highlight it. When we do that, we're going to have that portion of the hole that is along the cutting plane line. Now, what we then do is make sure anything that is an object line in the background, we're still going to portray. And you look at this portion right here, that's not along the cutting plane line. That's actually in the background. And in fact, what you're looking at there is this shelf as it goes around through the back. That's why we have a line all the way across this thing. Does everybody buy that? Countersink would work the same way, right? Where you got a countersink, they don't have this example on this chapter, but it would look something like this. And we put a line across there too, don't we? Okay, and it's that hole as it goes in the background. Another example is on page 785. Let's go look at that one. $16.43 is the figure, and in essence, I want to look at just section AA for this one. So section view AA is here in the top. You see the cutting plane line for it right here. So it's being taken as you come through these arms. Well, that's the section, two parts. Notice they're still showing the base and these negative cylinders that are down below it, because we're looking this way. So again, case of draw your section, show the stuff that is in the background that projects as object lines. Don't show surfaces that are hidden. Yes, Sean?
So if you were drawing that, you would, you would be told that that's what needed sectioned, and then you show everything else that you would see in that view?
Yes. Now I don't know that you would be told that. You might be said, hey, we need to describe this geometry.
Okay.
And you'd draw your multi-view and you'd say, you know what, I never do see these structural arms. And so then I would say, wow, I got to do something else. I don't know that you're going to get one of your supervisors, unless it's the designer, because engineers and architects, they're probably not going to pick up that you need a section here, not unless they've got some experience with it. Keep in mind that when you're looking at these people that are really what we call our designers, architects, engineers, they've got 2 credits of drafting behind them. 2, that's it. They're not the graphics professionals. Now, hopefully you've got somebody in between there called a designer, which is a person with a drafting degree that's probably got 5, 6, 7, 8 years experience, and they would say, hey, you know what, this is great multi-view, but we don't see this. Go ahead and section that. Okay, and then as you got more experience, you're going to start recognizing that stuff. Show things in the background, as long as they are not hidden lines. Any other questions on this one? There's a lot of different examples in there, but... All right, the next one. Hidden lines should be omitted. That's the whole point of doing a section, is to get rid of hidden lines. Now, there is a caveat to this, and it's in the text, and we're going to talk about it, but we should not, as a general rule, have any hidden lines. So we're going to go to figure 16.7 and 16.8. We'll start on 16.7. This is on page 763. So here's a case that really kind of covers 1 and 2 all in itself. Okay, so here we see our section line, we're pulling a full section on this object. So what's happening really along the section line, this one happens along the section line, and then we just talked about the counterbore, not all of it is along the section line. So we're going to show the stuff in the background, like this thing right here. Now there's some other things that happen in the background, like this would project down as a hidden line, right? Because it's still hidden from view at the section. This corner would project down right into here, but again, it's got to be a hidden line. And all we're going to do is confuse the process if we bring that into our section. So we do not project those. Now keep in mind, they still got this top view. They know this cut's back here. This is where all your dimensioning will occur on that cut, in fact. So that's the accurate section. So we project stuff in the back that we can see. Things that we can't see, we don't. Now there is a caveat to it. If you can bring a hidden line down that eliminates the need for another view, then you have that option. You can do it. Now this one, it's not going to help the view, it's not going to help the construction at all. Okay, so we wouldn't do it. Then we're going to go to the next page, figure 16.8, and here the author kind of gives you an exception to the rule, where here, okay, so our section's coming through on this location. You can kind of see where they've got it right here. Now what you cannot see on that is that this back cut right here is an inclined plane. We'd have to pull another section or something to describe that. They're saying, no, we'll just bring one line, bring it down through here, and that's going to eliminate the need for a whole nother view. Now, be careful when you do this stuff. If you bring it in, make sure that people can pick up on it. It's fairly obvious. This one where I've got the hatching on it, I'd make sure that hatching is at a definite different angle than that hidden line. It certainly wouldn't put it, in fact, I think this is really kind of bad form here. It's a little too close for me in this form or fashion. But what you're looking for is that hatching, we don't want it parallel or perpendicular to the objects around it. Okay? So you want it on some different angle. And this one works out pretty well, where you include a hidden line, and that way this surface right here is described. Now we don't have to do another view to get to it. So as a general rule, do not have any hidden lines on a section view. If you can add one and eliminate the need for another view, you may do so. Case of that will be pretty rare. Any questions on that one? Number 3. Actually, 3, 4 are pretty obvious, I think, that there's still rules and we're still going to go over them. Number 3, a section line area is always completely bounded by a visible outline. Never with hidden lines, never with air. So again, we're going to go to that counterboard. We're on the same page right here. So what we're talking about here, a section lined area, synonymous with hatched area, right here. It always has to have nothing but object lines on the boundary. Always. It must be completely bound. Remember, what does that section line area represent? What does it represent? Represents a new surface created by the cutting plane, right? So therefore, it has to have object lines around it because it's a surface that you can see, that you've created. Should I go any further on that one? Has everybody got it? It's kind of nice. We're going to go to the computer and look at the boundary hatch command today, and it'll be obvious boundary hatch command doesn't work real well without object lines around it. Now you can use hidden lines on CAD and hatch those areas, so you got to watch for that. That's why I put that last section in there on your statement. Number 4, a visible line can never cut across a section line area. And we're going to look at a few figures on this. Page 780 is where we'll start. So 1634, which is again this one's our offset section. And we already mentioned this when we went to the definition of the offset, but we'll kind of re-hit it. Remember, when we do an offset, we bend the cutting plane line at 90 degrees to pass through critical areas. Don't project these surfaces like it comes down here. Okay. So you've got one here due to those two bends. Don't project those. Let's go to 1638. So this one here, we're getting a little more complicated. Quite a bit happening on this little device. But again, if you look at every one of these section line areas, okay, they are all bound by object lines. Notice that as we come, we've got object lines here that cross through section lined areas. But what happens when I go from this section lined area across the boundary line to that section lined area? What happens?
Change planes.
Yeah, the pattern changes direction. Now, it's still the same pattern, right? This one's going 45 that way, that's going 45 that way. And that may be, but I'm going to say this is cast iron and this is also cast iron, but they're two different parts. They're just made out of the same material. What I can't have is one going this way, have an object line, and leave that pattern going the same way. Because that says they're both the same part and the same material. And we can't have that. And again, you have the assistance quite a few places, here, 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 and the same on the other side.
No, that's the same part, right? Is what that does?
We're actually going to use this on the next one too.
Okay.
Okay. Yeah, while we're here, let's just hit the next one. In a section, number 5, in a section view of one part, section lines in all sectioned areas must be parallel. Now, we use this for kind of geometric description so they understand what parts are which. It's like, again, this part right here, I know it goes, I see it right here, I see it all the way around here, and then I see it again down here. Those are the 4 places I see the same part on this one view. I know that this piece, okay, this is the same piece all the way around. It's actually gone away from right here, so I got this coming in, it's down here also. And the reason I know that because the hatch patterns are all parallel on those areas, so it's got to be the same piece. We have one unique one right here where they brought in a little bit different pattern. So you can tell people by having these patterns that are parallel how many different parts are going into these views. This one's a little complicated. Let's go to the previous ones on this. 1624, figure 1624. This one might make this is the most simple one, but I think it brings the point out most. So parallel section lined areas here and here, same part. Okay. Section line areas that are parallel here and here, same part. These are 2 different parts. Okay. So in essence, we're clamping these 2 parts together. And we tell that because our hatching is parallel for all the same piece. I'm going to jump across the page to 773 and look at just this section view right here. How many pieces do I have in this? How many pieces make up this drawing?
One.
Okay, 1. Declan, you raised your hand as 1. How do you know that?
I said 2, so I don't know.
Oh, you said 2. Maybe you must have put it like that and they had one hidden.
Yeah, so
Andy, you said 1. How do you know that?
Because all of the lines are all going one direction throughout the whole thing.
Yep. Yeah, since I'm using this pattern here, it's same pattern over here, same angle, got to be one part. If this was a different part, that pattern had better be changing. Maybe we ought to do another one. We'll leave it at that. Number 6, when there are 2 or more sections, each section is completely independent of the others and drawn as if they were not present. Now there's a couple of these I wanted to look at. So figure 1635 on page 781. Page 781. The case in point here we have 2 sections that are going to be 2 front views on this. Well, notice which one's labeled section A. So if I was to draw section A first, what do we do for section A? Since we're looking that way, we throw everything here away, right? It's all gone. Okay, so then we would project section A. Now when we come to section B, we can't draw it because we've already thrown it all away. We just ignore that section A ever occurred. And we draw B as if A wasn't there. Draw all sections as if all other sections are not there. I got one more. This one's not in your handout, but it's a pretty good example of this. Figure 1618 on page 768. And I think this is kind of common sense stuff, so I don't want to beat it to death, but it needs to be said. Okay, so if I do what's to do, here again I got 2 sections. Section A, in essence, I'm throwing all this away, right? To draw section A. So when I project section B, it wouldn't be with that gone. It would be as if A wasn't there. Does that kind of make sense? Okay. So when I'm doing section B, I would ignore that this one happened. When I'm doing section A, I would ignore that this one's going on. And we project each one in its entirety. Any questions on those? Okay. All right, the next one. Here we're kind of going to get into something new. Everything else we've talked about so far has kind of been a repeat of what we did when we were talking about our individual sections. The next 2, 7 and 8, we're going to kind of bring some new stuff in. Hopefully you've already picked it up in the text, but if not, you're going to see it now. So first off, structural item. What is a structural item? Let's go to page 784. Structural items like ribs. This is a rib. Any device that holds things up. Webs. We use a lot of webs as a structural item. We use them in circular devices. We use them in this case where they're looking at kind of a wide flange beam. I don't know if any of you have heard of what a moment force is, but this thing right here makes these 2 things a lot stronger. You've probably heard the old thing, remember Atlas, or somebody said, give me a pole long enough and I can lift the earth because you're using a cantilever. Okay, that's exactly what that is. And so it brings out a moment force, makes this much stronger. We see a lot of webs. You never see this, by the way, in orthographic projection except on this view. Lugs, lifting devices. Many times we got things where we got to hoist into place. We need lifting devices or places to bolt them also. So those are really what we're talking about when we say structural items. Now, I'm going to go read number 7. Thin features, such as ribs, webs, ear teeth, and other flat features are not suction lined. so as to not give a false impression that they have thickness and solidity or mass. Okay? Now, there is an exception to that rule that follows that. Let's look at figure 1624 before we go any further. Now, actually, that's kind of a bad one to look at. Okay. Let's go to 1642. We'll come back to 1624 in a minute. 1642, this is toward the end on page 784. '43 is what I meant to say, sorry. Okay, this guy right here. So, here in essence we have a bunch of flanges. So we've got these two circular devices. I'm guessing a shaft probably goes through here, power device off of an engine. We've got it bolted down. These are our flanges in between, or webs giving us that distance and structural support. Now, when they cut section B, okay, notice it's going right through these pieces. So B is cut. You see, looking into the hole, it's cut that way, okay, right through the middle. Now, when it comes through, this is how the projection would really occur if we followed the cutting plane line right through. But this piece right here, from here to here, and then the back side of it, same as this one, those are really thin pieces. We don't want people to think that, hey, you know, that's a big old honking piece of metal that's just rectangular. And that's what this looks like, right? Okay, so what we would then do is come in and say, you know what? I'm coming through from here to here. That's a really thin structural item. I'm not going to hatch that. I still draw the outline of it. Don't hatch it. Now, when I get right to the middle here, this guy has mass in that direction. Okay, because that's the whole point of this piece from here back to here, is to stop that vibration going that direction, right? That has mass. That gets hatched. Then I come to the back of it, no hatch, no hatch, hatch, no hatch. Okay. Structural items.
In a sense, what you're doing is almost like the offset, where you're cutting down and then you jump over and you get the thinnest, the structural part, and then you jump back.
Yeah, kind of. Another way to explain it. Okay. Let's go right down below here. Here you see some ribs that are around the circle. Now, as they come through, okay, look where this section's going. It's going right through this web right here.